the blood-brain barrier.
Let's assume that you could dye your entire body blue to be an avatar for Halloween. On the outside, your entire body will definitely become blue. One area inside your body, however, is somehow not affected by the dye, and that is your central nervous system, the brain and the spinal cord. Want to know why? It's because of the blood-brain barrier, and it is one big barrier to treating neurological diseases because it prevents most drugs from entering the brain. The blood-brain barrier, or the BBB, is literally a barrier separating the chemicals in the blood from the central nervous system. The BBB allows chemicals to enter the brain only if they help the brain to function normally, such as water and insulin. Let's look at the blood-brain barrier in the brain. Here is a cross-section view of a brain capillary. There are two major components in the BBB, the brain endothelial cells, which form the lining of the capillary, and the astrocyte end feet, which control the tight junctions between the endothelial cells. Because of these tight junctions, chemicals cannot get into the brain by traveling between the brain endothelial cells. So they can only get into the brain by passing through the brain endothelial cells. Basically, there's only one way of doing so, which is to be carried across the BBB by carrier and receptor proteins. These proteins collectively recognize all the chemicals that are needed in the brain and bring them into the brain. When other chemicals collide into the protein, nothing happens and the chemicals cannot enter the brain. Hence, the BBB limits the types of chemicals that can enter the brain. That explains why you cannot dye your brain blue, because the dye is not needed in the brain and hence cannot enter the brain. The mechanism of the BBB hence allows the brain to obtain the chemical it needs and at the same time prevents it from being harmed by possibly dangerous chemicals. Think of the brain endothelial cells as overprotective parents who wants to ensure that the son or daughter only obtains what they absolutely need so that they don't get harmed. That means that this would happen on your birthday.
Sweetie, here's your birthday cake. Where's the lighter for the candles?
Oh no, you won't light up the candles because fire is potentially dangerous. Here, the cake represents chemicals that the brain needs, lighting up the candle represents possibly dangerous chemicals, and the kid represents the brain. So as a quick recap, only chemicals needed for normal functioning of the brain can reach the brain, and possibly dangerous chemicals definitely cannot. Now we know why most drugs cannot enter the brain. Drugs are not considered to be chemicals needed for basic functioning of the brain and is not a substrate of carrier and receptor proteins. Hence, it cannot be brought past the BBB and cannot enter the brain. Scientists have found out ways of sneaking drugs across this barrier, one of which is to use Trojan horse molecules. Trojan horse molecules are drug molecules linked to the substrates of carrier or receptor proteins. In this case, this Trojan horse molecule is a drug molecule linked to insulin. Since the receptor or carrier proteins recognize insulin, the Trojan horse molecule will be allowed to cross the blood-brain barrier. This would be similar to how you want to pass through a door with a fingerprint lock that only your friend can open. You on your own would not be able to pass through that door. But if you stick with your friend and get past the door, it would be a lot easier. The use of Trojan horse molecules hence facilitates drugs to cross the blood-brain barrier. However, brain uptake of drugs just isn't all that simple. Even if the molecules are capable of crossing the blood-brain barrier, drug molecules present in the brain are often spit back out into the blood through the efflux system, limiting the number of drug molecules inside the brain. Intriguingly, the blood-brain barrier has different roles in disease progression in various diseases. But that also means that the blood-brain barrier itself already poses multiple challenges for us. Our understanding about the blood-brain barrier is still very limited, and there are a lot of its other mysteries yet to be discovered. Until that happens, the blood-brain barrier will remain as one of the major barriers in how we treat neurological diseases.